Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I'm Michael, founder of pgMustard, and this is my co-host Nikolay, founder of Postgres.ai. Hey Nikolay, what are we going to be talking about today?
Hi Michael. A few weeks ago we discussed what I call query micro-analysis, when we have only one query and we want to optimize this query. Let's talk today. Not just we want to optimize it, but we just want to understand how it works, how it will be executed on production. Let's talk today about the wide picture, about how we can analyze the whole workload and find the worst parts of it.
Yeah, so if that was macro performance
right.
analysis, this I've heard you call macro performance analysis. So maybe there's nothing wrong, but we want to be able to see at a glance. Are there any big issues? Is there a spike on some metric, something like that? Maybe it's monitoring related. Maybe it's a review of something in the past, that kind of thing.
Right. There are many goals that we can have in this analysis. For example, there are complaints like database is slow, right? We hear it quite often. Database is slow from application developers and other SREs and so on. And we want to identify the parts of workload which behave the worst. And this is one thing. Or we just want to optimize resource consumption to prepare for future growth. And we don't want to spend more for hardware, so we want to find the worst behaving parts of workload and we optimize them. There are many different cases.
Yeah, so I mean, it could be an application developer telling us, it could be customers reporting that there are issues, and we want to find out which part is slow, or maybe we want to show them that there isn't an issue, or we can't see anything database side.
All right. One of the cases I like especially is when we perform workload analysis as a whole during various kinds of preparations, various kinds of testing before we deploy. And this is also interesting, and there we can also try to understand are all parts behave well, or there are not so well behaving parts, so we should optimize before we deploy. But let's just start from maybe historical aspects of it. Like 15 years ago or so, we didn't have pgStar statements, which right now is standard de facto extension for macro analysis, and there is consensus in community that pgStar statements should be enabled in all Postgres installations. By default, this extension is not installed, but everyone should consider installing this extension because it has very, very small overhead, but it's like the place where you probably want to start your macro analysis, understanding how workload behaves. But before pgStar statements, we had only logs, and the idea was, okay, we log all slow queries, for example, queries which are longer than 1 second, execution of which is longer than 1 second. And I remember when I was briefly, just 1 week, I was a user of MySQL and switched to Postgres, and then it was a confirmation of my choice was right. It was confirmation when I found that in Postgres I could go down below 1 second. I mean, log mean duration statement timeout. And the log queries, for example, which are above 100 milliseconds. But in MySQL, it was not possible, and 1 second was the lowest value. Right now, they fixed it already, and you can go down below 1 second. But at that time, it was in 2005, 6, 7. So, and we log all slow queries, and then we can parse logs, and I remember we had a tool called pgFuin written in PHP, and then pgBadger was created, written in Perl. It's much more, it's much better in terms of performance. It has much more features and so on, like more robust. It's being developed still. And by the way, yesterday they released version 12, I think. I saw some in the news, right? So pgBadger 12, more and more features. Right now it can work with auto-explain and many things. So the idea was, let's parse those queries and remove parameters from them, and so aggregate them. It's the process which in pgStart statements source code terminology called normalization, query normalization. And then we will show the worst, according to some metric, the worst query groups. But the problem with this approach that this is only the tip of the iceberg. We might have many more queries which are not visible in logs, but they produce the most load. Sometimes like 90% of load is produced by queries which are under log min duration statement timeout. So some DBAs used approach like let's enable all query logging with duration for a few minutes and collect logs. And some, including myself, found a way to store logs in memory. It was quite like risky, so I used it only a couple of times. So we create RAMFS. How's it called? We create the drive in memory, and we put logs there, but it's like only like I don't know, like half a gigabyte because memory is expensive, and we make very aggressive rotation, so we don't let Postgres log to be to saturate this small disk. But since it's in memory, we can afford logging a lot, and we can set log min duration statement timeout to 0. Meaning that let's log all queries.
That's the big downside of logging does have an overhead if you're logging excessively, or if you so that seems to be a good argument for not well. That's why we don't have to anymore, right?
Right. Yes. Logging overhead may be very big, and it's not noticeable until some point when your drive where you write logs is saturated in terms of write disk I/O, and then everything goes down, and it's not fun. Like this is one of the worst observer effects I had in big production cases. And it was very painful. So I don't recommend to go down to 0 in terms of log min duration statement blindly and without proper preparation. But anyway, this right now we consider as an outdated approach because we have pgStart statements, right? And we don't need to log all queries anymore. We still need to log some queries because pgStart statements doesn't have examples. In pgBadger reports, aggregated normalized queries, I call them query groups. pgBadger provides a few examples, and this is very important because in each query group you might have different cases. The same query, abstract query without parameters, might behave very differently in terms of execution plan, depending on parameters. So when you already identified queries you want to improve, you need examples always, and this is tricky. Guessing examples is a big, not yet solved task. I think it's a good task for machine learning and so on. I'm very interested in this area. Like, if someone of our listeners also sometimes interested in this area, please let's talk, because I think it's a very interesting area to automate, to improve, to allow us to improve more queries with less time, right?
But at the moment we can patch it together via a mixture of pgstat statements and the logging.
Yeah, we can combine logging and pgstat statements. Also, query ID helps in very recent Postgres versions. Before query ID, we used libpq query from Lucas Fittel, right? So we like it's an additional ID, and the good thing about this library or tool that if you apply it to already normalized query, it will produce the same fingerprint as for non-normalized raw query. But anyway, if you use logs, you can find examples. But another source of examples of queries is pgstat activity. But in most cases where like lack of DBA involvement happened, I saw that track activity size, or how it's called, I always forget. There is parameter which says the maximum length of pgstat activity.query column. And by default, it's 1024 only.
Yeah.
Right. And it's not enough. ORMs or humans, they can create much bigger queries these days. So we want to put like 10K there or something. Overhead is very small, so I always also recommend to increasing, but increasing it requires a restart. This is the main problem.
So one of those ones you have to do at the beginning normally, isn't it?
Yeah. So this parameter should be increased, and if we increase it, we have more opportunity to get samples of queries from pgstat activity. Then we can join or match them with pgstat statements data, and then probably logs are not that needed, unless you use auto-explain, because auto-explain also very useful. And again, your article about the overhead and how to measure it, and the idea that sometimes it's not that big is good. And maybe you want also this, because in this case you see plans exactly as it was during execution, because plan flips happen as well.
Yeah, I was going to ask actually, we've talked about the overhead of these things a little bit. You mentioned the overhead of pgstat statements is low. I've seen some people mention that they've tried to benchmark it and struggled, but have you seen anybody actually try and struggled to measure the overhead on a normal workload? Have you seen any benchmarks of it?
I haven't. I trust already current experience, but we can do it. I mean, it's not this is not the most difficult benchmark. I think in Postgres ecosystem. So we can just, of course, it's good if you can benchmark for your own workload. And the question is how to reproduce workload in a reliable way, so each run is the same or very close to each other. And then we can just use we can use various metrics which database has without pgstat statements. But for example, from pgstat database, we should, if we enable track IO timing, and by the way, usually we should enable it. Of course, we also discussed it. There are cases on some hardware it can be expensive, it's worth checking. But if we enable it, we can produce workload, check this parameter, then reset, produce, or we can check throughput and especially latency from application side. If we use application called pgbench, which I don't know why Ubuntu ships it in server package, not client package. But if we use that application, it reports all latencies, or sysbench, anything.
Yeah, what I meant, I think when I said struggled, what I meant was the variance of each run is larger than any overhead. So you can't either you're saying you can't say the overhead's zero, right? Because it's definitely doing some work, but it's not necessarily measurable.
It should be a few percent.
I don't think it. I think it might even be lower than that for some OLTP workloads.
Yeah, well, so I think benchmarking is the area we probably need to discuss one day separately.
Yeah.
But my general advice is, by default, many benchmark tools, and pgbadger is no exclusion here, they behave like they don't do load testing, regular load testing. They do edge case of load testing called stress testing. They do let's load it 100% by default. That's why I suggest usually to find the spot in terms of TPS. You can control TPS in pgbench. You find a spot like loading your system in terms of, for example, CPU or disk IO, 25%, between 25 and 50, emulating normal days of your production. Because if it's above, you already should think about upgrading or very heavy optimization. And in this case, you should check latencies and compare in each run. And in this case, variance should be the same. I don't know why they were different. Something is wrong. I would like to see the concrete case and understand.
Yeah. Well, so now that we have pgstat statements, there's a few things to mention there. It's, not on by default unless you're on a cloud provider. They often do have it on by default. So people do need to load it. if they don't already. I come across quite a lot of customers who don't. If they're self-managing, they're not even aware it's a thing. So that there probably are a bunch of people out there who don't have it on, even though the experienced people
Everyone should have it.
I think so.
Yep.
But then again, so there are a few default settings there that I think can be improved. There's like is it 5,000 statements or 5,000 unique parameter?
Yeah, you are talking about pgStartStatements.max parameter, which is, as I remember, 5,000 by default. Usually it's enough, but in some cases it's not enough when your queries are very volatile in terms of structure, not in terms of parameters, because pgStartStatements during query normalization removes parameters, but in terms of the structure. If you just swap two columns in your query, it's already considered as two different cases, two different entries in pgStartStatements table. And pgStartStatements max is 5,000, so you can increase it, but as I remember, only to 10,000 maximum. I don't remember exactly, but what I usually recommend, not like thinking about, okay, I mean, why we care? Because if pgStartStatements has metrics which just grow over time, they incremental metrics like total time, total exec time, total plan time, because they split in Postgres 13, as I remember. In this case, we need two snapshots to analyze. We need two snapshots and two numbers, and then difference between those two numbers is what we have during our period of observation. Snapshotting is absolutely needed, otherwise it's not like the manual approach lets reset statistics often and then use only final snapshot, thinking that we started everything from zero. It has downsides. For example, filling with new entries has overhead as well. If you check source code, it says when we add an entry, so there is a lock there, and it might be like noticeable during like dozens or sometimes like 100 milliseconds. It can be noticeable for all workload. So it's better not to reset very often, in my experience. But and anyway, it's not practical to reset them. You lose information as well. Then the question is like how often we have evictions of rare queries, and like what is the like some drift of our query set. And you can see it. You can compare the difference between two snapshots, for example, 1 hour between them, and you can see which new queries and queries which disappeared from the list. And this difference indicates how like eviction speed. And I've noticed that. Some, for example, Java applications, they use a set application name to something very unique, including some maybe process ID or something. And pgStartStatements cannot normalize so-called utility commands, and set is utility commands. So these queries are considered as separate, all of them, all set parameters. In this case, you might want to turn off pgStartStatements track utility, which is on by default. Right, and in this case, you don't, because I haven't had cases when we do need to analyze the speed of set commands. Well, maybe it might happen, but in my experience, not yet. So it's better to just turn it off. It's on by default.
That makes loads of sense. I think talking about the snapshot comparisons, I think that must be how the cloud providers all do it. And a lot of the dashboards that you'll see in RDS, Google Cloud SQL, there's a bunch of other ones as well, like or even like open source tools. So talking of tools that have had releases recently, PG Hero came out with version 3, I think, yesterday.
I haven't noticed. Good, interesting.
Yeah.
It's really very lightweight and a good tool, like for small teams. I enjoy like
and based on pgStartStatements again. So it's it's the basis for lots of these. But back to the cloud providers, by taking the way they get historic data is by taking these snapshots and rolling them and comparing them to each other, not by rolling it forever on the same. Right. They won't run a reset once a year, for example, if that makes sense.
Right. Well, so why do we care about this eviction speed and this like transition to new list, because we want to analyze the whole workload, right? And in this case, of course, disabling track utility, we will don't see this utility part. But if you consider it small, we can do it. But we will have more real queries in our pgStat statements. And we will have 5,000 by default. It's quite a big number. But the second place where cutoff can happen is monitoring system or cloud provider. I don't know. Like, they usually store like 500 only or 1,000. They don't take everything, because it's expensive to store everything in monitoring system. You need to, if you want snapshots, samples of pgStat statements, snapshots every, for example, minute. Imagine how many records you need to store if every minute you store 5,000 entries from pgStat statements. So usually they also cut off, and making decisions what to remove, what to leave. We usually think about which metrics are the most important. And
yeah.
So
should we so actually I think you already mentioned it briefly, but the total time is my favorite. I know we've talked about
mine as
timings
well,
versus
mine as well, but I saw people which prefer not total time. Actually, in my team, there are such people which prefer, for example, average time, mean exact time. Or mean exact time plus mean planned time, because we probably want to combine them, because the execution includes both planning and execution. Okay, tautology. Sorry.
Yeah, but we call that total time by summing the two, but there's no such parameter.
Total already used in different contexts.
Exactly.
Well,
so. But the problem, this goes back to our conversation about logs versus pgStat statements, though. The reason, I guess the reason for you as well, but I'd be interested, the reason I prefer total time is you could easily have your biggest performance problem being...
Sorry, you understand why total is used twice here, right? Because total is sum of all timing for... I mean, there is total exact time and total planned time.
Yeah.
Total. No, it's not good. Like total whole. How to name it?
Yeah. Well, they don't, but we can sum those at the query level, right? We can sum the two of them if that's what we care about. But what I guess I was trying to say was our biggest performance problem could easily be a relatively fast query which has a really low average mean. Average by mean time. So it could be on average 20 milliseconds, but it's getting run so many times, and maybe it's still not optimal. Maybe it could be running in sub 1 millisecond, and that could be our biggest performance opportunity. And by looking at total time, total execution time plus total planning time, we could see that could rise to the top of our query. It could be line number 1. Whereas if we're looking at average time, we could easily, so many queries that only run a couple of times that take a few seconds each.
Right.
They'd be long above it.
This is an interesting topic. Which metric is more important? By the way, the lack of words here indicates that the topic is quite complex, right? I mean, English doesn't have enough words to provide it. I'm joking, of course, but interesting. Total what time, if you combine both exec and plan. Some word should exist, and we probably already use somewhere. So total versus average or mean time. In my I came to a conclusion like this: if we aim to reduce load on if our primary goal is resource optimization, if we want to prepare for future growth, we want to pay less for cloud resources or hardware, total time is our friend, because this is well, of course it includes some wait time as well. For example, if we have a lot of contention and some sessions are blocked by other sessions, it also contributes to total time, but resource consumption probably it's not that much, because waiting is quite cheap usually, right? But if we forget about this a little bit, total both plan and exec time, if we combine them, this is our time spent to process our workload. If we know that we analyzed everything, this is our time. This is how much work we did. I mean, Postgres, how much work Postgres did. We can even take total time and divide it by observation duration, and we will understand how much time we spend every second. I call it metric is in seconds per seconds. My favorite metric. If, for example, if it's 1 second per second, means that we roughly one core could process this. It's very not like we forget about context switches here, of course, and so on. But it gives some feeling of our workload. If we have 10 seconds per second needed to process, it's quite good workload already. We need probably some beefy server here. As for average time, mean exec time, or exec mean time, mean exec time, mean plan time, these numbers are targeted, are most useful when we have a goal like let's optimize for best user experience.
Yeah, so I guess that's our 50th percentile, isn't it? With the is it? No, it's not. It's not. So I even then I don't even like mean for those, because I'd much rather look at a P95 or something and look at it client side, not database side.
Well, it depends, but sometimes, as you said, sometimes we had very rarely executed queries, but quite important ones. For example, it can be some kind of analytics, not analytics, but some aggregation and so on. And the average is terrible, and we do want to improve it, because we know that users who look at those numbers or who use these queries, these users are important. For example, some our internal team analyzing something, or I don't know, like finance people or something, and some kind of more analytical workload. Not necessarily analytical, but I hope you understand, right? So.
I think I understand. So, give you an example. When I was at a payments company, it was like a batch. It was daily batch payments. We had a deadline to submit a file. It was like a 10 p.m. UK time deadline, and the job literally had to finish before then. And as this job got longer and longer, it got closer to that deadline, and then it forced some work. So maybe that wouldn't have shown up if we'd looked at duration or total time. But yeah, but I also think those kinds of issues often crop up without you having to do this macro analysis work, because somebody's telling you about them.
Yeah, so if we decided to order by mean time, sometimes we see on the top something that we say, oh, it's fine that it executes a minute, because it's some cron job and nobody cares. If it's just select, for example, and no locking involved, and it lasts 1 minute, it's not a big deal. So we probably want to exclude some queries from top and ordered by mean time, average time. So. In this case, for total time, it's not so. I'm usually really interested in each entry from the top. But mean time that's why I also prefer total time. But I see people use mean time successfully, caring about mostly users, not about servers. So roughly, total time is for infrastructure teams to optimize for servers, while mean time is probably interesting to application development teams and for humans, right? So very roughly. Mm-hmm. Well, there is also calls, important metric, right? And in calls, if we check calls, sometimes calls is important because I see my video frozen. Let's ignore it. So order by calls and getting top N by calls is also important. Why we discuss which metric to choose? Because when you build good monitoring, you need to choose several metrics and build a dashboard consisting of multiple charts, top N charts. Top N by total time, top N by mean time, top N by calls, for example. Why calls? Probably for database itself, it's not that important. And if the most frequent queries, they might produce not the biggest load. Of course, if there are a lot of very, very fast queries, I would check context switches, for example, and so on, right? And think about how CPUs are busy in this area. But I've noticed that sometimes we want to reduce frequency of some of the most frequent queries because overhead on application side is terrible. This is unusual approach because sometimes people optimizing workload or database, they think only about database. But I had cases when optimization, for example, let's take top 3 order by calls, and just reducing the frequency, we can throw out 50% of our application nodes. Can you imagine the benefit of it?
The cost saving, right? But so it could, just to give an example from the application side, I guess that would be one way of spotting potential N+1 issues, where if it's the same queries getting executed over and over again, that's the kind of thing it could point to.
Right. So it's interesting. Like I think I don't understand all of aspects here, and I think we lack good documentation how to use pgStart statements. So many angles, so many like derivatives as well. But I would like to finalize discussion of metrics. I wanted to mention also I/O metrics, shared buffer hits and shared blocks. They call shared blocks read and hit. Right? Let me check. Shared blocks hit, shared blocks read. Also dirty and written. But if we consider only read-only, well, local and temp additional. But let's just, if we discuss everything, we need an hour.
Yeah.
Right? So many aspects. But I wanted to mention only a few, like hit and read, shared buffers hit and read, because it's okay. If we talk about this only, interesting thing here is that sometimes monitoring system thinks that read is enough because it's the slowest operation. As we already discussed a few times, Postgres doesn't see the actual disk read.
Like the operating system cache versus the disk reads.
Yeah. So this read is from page cache. Maybe it's disk read, but maybe not. We don't know. But usually, monitoring system says, okay, ordering by shared blocks read is the most interesting. But I had cases, at least 2 times, when I really needed pgStart statements shared blocks hit, and finding the most because working with buffer pool in Postgres, the shared buffers, was so intensive by some query group. If you don't have it in monitoring, you need to start sampling pgStart statements yourself, writing some scripts on the fly. It's not fun at all. So I think most DBS who have experience, they have something in their toolset. But for example, pgCenter can sample it for you. You can use it as ad hoc tool. If you don't have it in monitoring and you have problem right now, for example, but I also suspect they lack hit or top n by hit number. So these angles and new metric wall. Let's find queries which generate the most the more wall data. Let's order by how's it called? Let's check. I have the list here. It's called
full page.
Yeah, wall records, wall FPI, full page inserts, and wall bytes. 3 metrics added to Postgres 13. I didn't see them yet in any monitoring. I hope. Oh, maybe our pgWatch 2 Postgres.ai edition, it has it already, right? So it's
I remember this was added to explain in version 13. Was it added to pgStart statements the same time?
It was same time, yes.
Yeah, makes sense.
And it's so good. Like order by like we want to reduce wall generation, definitely, because reduction of it will have very positive effect both on our backups subsystem and replication, both logical and physical. So we do want to produce fewer wall records or fewer wall bytes. all full page.
Or
writes.
full, exactly.
Yeah. So I never used it yet. I hope soon I will use it someday. And so I know that it's there, but never used it myself yet.
Yeah,
And
talking about this has given me an idea as well. We talked a while back about buffers, and one of the things we do on a per query basis is look at the total sum of all of the buffers. And I know that doesn't make tons of sense, summing dirtied buffers plus temp buffers plus local plus shared.
we can call it total IO or something.
Yeah,
Logical
exactly.
IO.
Or some kind of measure of work done, and actually summing all of those and then ordering by that and looking at the top 10 queries by total IO.
I think it's a smart idea. Each IO has some cost. And if we find queries which generate most IO operations, involve most IO operations, of course, it's a good way, it's a good angle for our analysis.
Yeah.
What else? We mentioned that we deal with page cache when we look at IO.
Yeah.
But sometimes we do want to order by real physical disk IO, right? And there is such opportunity for those who manage Postgres themselves. It's called pgStat cache, additional extension to pgStat statements, extension to extension, I would say. And it provides you very good things like disk reads and writes, real physical disk reads and writes, and also CPU. Sometimes you want to find queries that generate the most load to your CPU, and it even distinguishes system and user CPU. It's
cool.
It's good, yeah. And also context switches. So it's very useful extension if you care about resource consumption and you want to prepare for growth and you want to do some capacity planning, and before that you want to optimize.
And I think you've said before, but did you say it's not available on most managed services?
No, I only know Yandex managed services. They installed it by default, but I'm not aware of any others. So yeah. Also, there is another way to analyze workload we didn't cover today at all, wait event analysis. This is what RDS, for example, provides as like starting point actually for workload analysis. I think it came from Oracle World Active Session History Analysis.
Ash.
So someday let's discuss it and compare it with traditional analysis we discussed today.
Yes, and for anybody that is aware of Ash and wants it for Postgres, there is I've heard it called PASH. Yeah, PAS. PASH as well. Yeah, exactly.
But it's only it's a Java client application which will sample, do sampling from pgStat activity, but it can only be used as ad hoc tool if you're in the middle of incident. Yeah.
Same as Ash, right? Isn't it?
Well, you can install, for example, a pgWait sampling extension, and immediately in our pgWatch 2 Postgres.ai edition, you will have the same similar graphs as Postgres Performance Insights in RDS have.
Nice.
I think Google also implemented it. I'm not 100% sure, but I think they did. Yeah. Or pgEd Center, I mentioned earlier, also a good ad hoc tool. It also has wait event sampling. But let's discuss it some other day.
Well,
so
we also have an episode on monitoring that people can go check out. A deeper discussion on that.
And microanalysis. It's good to distinguish these things. Sometimes you have already query. You need to go inside it and understand what's happening. Why is it so slow? But sometimes you have no idea where to start. Database is slow. Everything is bad. In this case, query analysis, macro analysis is definitely worth conducting. So, yeah.
Wonderful.
Okay, sorry about 40 minutes again. So it's again longer than we wanted.
It's good.
As usual, let's thank all our listeners who provide feedback. This week was excellent as well.
Yeah, we had a lot of great suggestions. It's been really good. Thank you.
Yeah, this drives us. Thank you so much.
Yeah, really appreciate it. Well, thanks again, Nikolay. I hope you have a good week and see you next time.
As final words, like, share. Thank you. Bye.
Take care. Bye.